Our next transformation that we're going to be looking at is reflections. Now, a reflection, a transformation that creates a mirror image of the preimage, so that if A is on the line of reflection, then it is its own image. And if B is not on the line of reflection, then the reflection is the perpendicular bisector of B prime. Now, in both of these, we talk about a line of reflection. This, quite simply, is the line that a preimage is reflected across to create the image. So in our diagram that we have below, we can take a look at our preimage, which is in black, and our image, which is in blue. You can see that A sits on the line of reflection, which is M, so A is its own preimage and image. B, however, does not sit on the line of reflection, which is M, so the line segment that runs from B to B prime is bisected as a perpendicular bisector by line M. Now, the way that we can write and notate these reflections is, if we want to do a reflection across M, we say R sub M of C equals C prime. And what this says is the R stands for reflection, the M tells us what we're reflecting across, and then what is it that we are reflecting becomes the new image. So there's different ways that we can do this. We can also do reflections of line segments as a whole. For instance, we could say that's the reflection across M of line segment BC is line segment B prime C prime. And what that would notate is that this line segment here is reflected to here across line M. So how can we use these images and preimages in order to create our new designs? So we have here a triangle ABC with B sitting on the y-axis. And what we're going to do is I want to reflect across the y-axis the entire triangle, sorry about that, of A, B, C. And from that I will create triangle A prime, B prime, and C prime. So first, how do we do this? Let's begin with point B. Since B sits on the line of reflection, it will become its own image. So we have here B prime. Next, you can simply, with these vertical or horizontal reflections that are possible, count the distances. From the y-axis to point A, we move 3 to the left, so its image would be moved 3 to the right and end up right here as A prime. Now we can use a similar method for finding C prime. C sits 1, 2, 3, 4 units to the right of our line of reflection. So we're going to go 4 to the left, 1, 2, 3, 4, and end up here, calling this C prime. Now, in order to create the triangle, we complete the line segments that exist for it, and we have triangle A prime, B prime, and C prime. So a lot of it is being able to count your distances. You can do this similar to finding slope, find your vertical change, your horizontal change to the line of reflection, and then do the same going the other way. You know, if we were to take this and reflect it across the x-axis, B would end up here, C prime here, A prime about here, and we could create this other triangle real fast, but without the grid going down, it's a little bit hard to get exact points. But you can reflect across different ways. So, how do we name reflections, or how do we write the rules to do them? Now that we can do a reflection, let's look at the rules. So in this diagram, each triangle is a reflection of something else. what we want to do is be able to write a rule for triangle 2. And in order to do this, what we do is we look at triangle 2 and we see what is it a reflection of. Well, we could try to make triangle 2 a reflection of triangle 1. That would mean that this vertex here on the lower right, based on shape, would have to go to this vertex here. Vertex at the top would end up being the bottom, and the lower left is the right angle, be the upper left. There is no set way where all these are being reflected across the same line. Next, I could say that 2 looks a lot like 3. But what we're seeing here is a straight distance. There's no reflective property, no mirrored image. So that doesn't work. This would make a good translation, but does not make a good reflection. Now when we look at 2 and 4, we can see that all points have this idea of being equidistant from line K. So what we can do is we can say that triangle 2 equals the reflection across line K of triangle 4. And using a little bit of properties of symmetry, we could also say that triangle 4 equals the reflection across K of triangle 2. And now, in similar fashion, we could also do the same thing for finding reflection of triangle 1. Based on location and proximity, triangles 1 and 3 are reflections of each other across line M. So, writing this rule, we'd say that triangle 1 equals a reflection across M of triangle 3. And, using a reflexive property, triangle 3 equals a reflection across M of triangle 1. So being able to write a rule in the proper notation to match what we see, and being able to take directions and do the reflection that is given. Now we don't always have to do a reflection on the image like what the example saw. We can do it independent like what we are seeing here in these diagrams. So again, a little bit new notation. Make sure you have the notation down and understand it, and be ready to apply this, especially when we start looking at those composition of functions, because we can do reflections and translations together as we have these. We'll continue to build on different transformations and look at all the compositions together.